Hi, this is Adrian with Applied CAX, and today we're going to talk about TET to HEX transition meshing. So we've got a little manifold part here, and we need to do a little bit of geometry prep before we can mesh the part, mainly slicing the part up. So geometry, solid slice. If you're familiar with hex meshing, you understand how to subdivide a part for hex meshing. So I am going to first slice this up in the ZX plane, and I'm going to cut off these straight sections of pipe and back away from this intersection about a ½ inch. And that way these parts can be hex meshable. I'll do the same for the lower region here, using right-click previous command to bring up solid slice again. And this one I want to slice in the YZ plane at the top of the flange, at this transition region, and then one other region just about a ½ inch above that in the X direction. All right, another thing I'm going to need to do is if we use the draw erase toolbar to look at these flanges, they're going to have these little imprint faces where the pipes come in to meet them. And I need to embed that face all the way through. So there's a little annulus there to transition the mesh. So that's going to be solid embed face. And I'll use pick front to grab these using the default settings. And same thing over here. Now when I turn off the draw erase toolbar, you can see how those have been punched through here. One of the tools I like to use before meshing is in the meshing toolbox. It's called the Entity Locator. And it's kind of nice because you can use it to find short edges or slivers. So let's look for our shortest curves here. And we'll kind of scale this down. We can do the 2%. And you can see it's labeling these with a little ID number of the curve, short curves in the model. And it's always good to look at this just to see if there's any potential problems. And I noticed in this model having some short curves right here. You can actually see there's a tiny little split line just above my slice. So I'm going to use the meshing toolbox. I'll use feature removal, and I'm going to remove curves with the combine surface option. This is going to allow me to get rid of these surface splits here and avoid that tiny little surface, which would cause poor quality mesh. So I'm going to do the same on these other regions here, removing these. And last inlet right here. Now, if you wanted, you could go back to the locator, show your shortest curves. We're looking at the 6 shortest curves there. Those all seem reasonable. All right. Control G, refresh the view. Let's set up our sizing. So we're going to do size on solid, and we want to grab everything at the same time and go with hex meshing. I'm going to bump this size down to something like 0.2. All right, so it says everything is hex meshable, but this actual splitting complicated part here in the middle, and that's reasonable. If we turn on our mesh sizing, you can see the approximate size we're going to be working with. One of the things that I like to do when I've got piping like this, tubes modeled with hex elements, I want to make sure the inner and outer diameters have the same number of elements. So I'll use size on solid to do my general, and then size along curve to set my specific sizing in some of these regions. So I'm going to do pick all inside and just grab kind of these circular curves here. And there might be a few extra in the selection that I could remove. There we are. And then same thing over here. Just the circular curves. And this is going to allow me to assign all those the same mesh size. And let's do the same over here. I'm going to square up my view, click on the view axes, and we'll just grab all of these circular curves. Now this is the nice thing about the pick all inside. So I can grab these, and it's only grabbing those circular curves that are all inside my selection box. All right, so now I should have a nice concentric mesh there. Let's go to actually meshing the part. We start with the hex meshing of solids. So I can select everything and remove solid number 8 here. I know that's not going to hex mesh. And we can load a material. Default settings for the hex mesh. Then we come back with the second meshing operations, TET mesh. We choose this here, and we're going to use this TET pyramid mesh option. So since these surfaces are matched to the neighboring hex meshed surfaces, it's going to set up a transition mesh in that region. I'm also going to ask it to merge all the nodes together. Okay, let's turn off our geometry and take a look and make sure that FEMAP did this the way we want. So what I'm looking for is all these different solids have a continuous mesh, so I shouldn't have any sort of free surfaces. Some of the tools I'll use for this is I'll turn off my filled edges and turn on transparency. And if you have free internal faces, you'll be able to see them this way. You can also use the clipping tool. And with the clipping tool, you can actually slice through, and that's another way to see internal faces. So if we look at this region right here, even though there's a slice in the geometry there, we don't see any element faces there. The last tool I'll use to identify potential free edges or problem areas like this is called the feature line tool. So let me turn off my clipping plane. Feature line is new. Under view options, the tools and view style, you can turn on the feature line option. And you can see it puts a dark outline. You could choose the particular color that you might want for this. Sometimes using something bright makes it easier to see. And you can see free edges. And you're going to get a transition region between different element types. But you could use this in combination with the Draw Erase toolbar to make sure that you're only seeing free edges where you expect. Okay, so that covers it for our HEX to TET transition meshing. Thanks for your time.